All right, thank you for joining us today. And in this video, we are going to talk about Leibniz theorem. Let's jump right in. So, with Leibniz theorem, it's a formula used in calculus for differentiating the product of two functions multiple times. So, we all know product rule, right? And product rule, like find the product rule of, let's say, x squared e to the power x. It's very simple, right? You just do it for the first time, then you are done. But here, we want to do the product rule to the nth term. So we cannot be doing the product rule just one by one up to the nth term. So that is where Leibniz theorem came in with a formula that is going to help us to just do this in a quick way, right? So it provides a systematic way to compute a higher order derivative of a product of a function, right? So now let's look at how we are going to use Leibniz theorem. But first, let's learn the formula, right? So we have u and v, they are functions of x, and we want to look at the nth derivative of their product, right? So d over dx to the power n of u of x, v of x. So now this is equal to this is equal to summing k from 0 to n combination k, then we have u to the power k of x, and then we have v to the power n minus k of x, right? Don't get worried. I will simplify it and you will see that was maybe the formula that you know already. So I'm going to make sure this is equal to y. So I'm going to have dn over dx to the power n of y, which is equal to, then I'm going to expand. When k is equal to 0, I'll put it inside. When k is 1, up to the nth term. So I'm going to have n combination 0, u to the power 0 of x. So let me just ignore the x for the meantime. Then v to the power n minus 0 plus n combination 1, u to the power 1, v to the power n minus 1. So I'll expand this up to the nth term, right? N combination n, u to the power n, and then v to the power n minus n, right? Now, when I differentiate this, I'm going to have y to the power n, and then this is the same as n combination 0. This is u to the power 0, v to the power n plus n combination 1, u to the power 1, v to the power n minus 1 plus up to n combination n, u to the power n, and then v to the power 0. Now, we can rewrite this one as y subscript n, and we can write this one as n combination 0, and we write this one as u to the power u0, v n plus n combination 1, u1, v n minus 1 plus 1, 2, 3, and then we have n combination n, u, and v naught. But one thing that you need to know is u naught is the same as u, right? It means that we are not the function is not differentiated, and then v naught is also the same as what? V, the original function that they are going to give it to you. So this is the Leibniz formula. We can also use this one to also work out, right? Then the binomial expansion that we have is n combination k. N combination k is the same as n factorial divided by k factorial, n minus k factorial. So this will help us to simplify everything here. So let's take one or two of them to see how we are going to do the simplification. So let's take example n combination 0. This is the same as n factorial divided by 0 factorial, n minus 0 factorial, right? And this is going to give us n factorial. 0 factorial is 1. and then n minus 0 is n. So we are going to have n factorial. So this guy will cancel this guy, and we are going to have 1. So this, you can even have it off head that n combination 0 is 1, or if n is any number. But remember, n is a natural number. Let me put it that way. Yes. So what you need to know is, even if I have 2 combination 0, 1, 3 combination 0 is also going to give us 1. Let's look at n combination 1. This is n factorial divided by 1 factorial, n minus 1 factorial. 1 factorial is still 1, right? But let's look at something here. We can see that we have n minus 1 here, factorial here, and we have n here. So we can expand factorial. We can expand factorial. If I have n factorial is the same as n minus 1, n minus 2, up to 2 times 1 times, 2 times 1, up to 2 times 1, right? So this is how I can do the factorial. So I can go like n minus 3 up to the last here, right? So if that's the case, here whenever you are doing something like this, you try to expand this to get what is in here so that you can cancel out. So this one, I have n minus 1 factorial. So I'm going to expand the top as n minus 1. As soon as I can see n minus 1 here at the denominator, I'll stop there by introducing the factorial. 1 factorial is 1, so I'm going to have n minus 1 factorial. This cancel this, and I have n. So n combination 1 is what? N. Let me do n combination 2 for you to understand it better. So this one will be n factorial divided by 2 factorial, n minus 2 factorial. Now I'm going to expand the top, but I'll stop when I see n minus 2. So I'm going to have n minus 1. Now you can see that here we don't have n minus 1 at the denominator here, as we saw from here, right? So I need to continue the expansion, n minus 2. So I go to n minus 2, then I saw that I have n minus 2 here. So I'll stop and bring the factorial there. Then I'll have 2 factorial is 2, n minus 2 factorial. Then this one will cancel this. So I'm going to have n minus 1 divided by 2. So n combination 2 is going to give us this. So you can try expanding some of the factorials. Maybe you can try of like n combination 3. You can even try n combination n and see what you are going to get. So that is the idea with Leibniz formula. So don't forget, we are going to use this. We are going to use this one too, and we are going to use this one too in our calculations. When we are doing some of the calculation, we need to remember this so that we can learn how to do the expansion. But for me, I know that n combination 0 is 1. This one is also equal to n, and this one is also equal to this. But know the process in case you forget that this is 1n and this, then you can just go through the process to work out, right? So in the next video, I'm going to give you the tips for calculating, Leibniz, or the process of getting through Leibniz theorem, right? And then we will start with let's practice example, and then we just go ahead. See you in the next video.